Hi, everyone. Thanks for coming to my talk, especially because at this time you also have Ty and you have Eugenio as well talking, and they have pretty good talks. So thank you very much for coming to this one. Hopefully you learn something today. Like the title suggests, today I'm going to be talking about what I've been doing at Sky for the last year and a half or so. And I mean, the title suggests that it's going to be a very honest retrospective. So I'm going to be showing code that I'm not really proud of, that our team is not really proud of, and you're going to see like a few bad things, I guess. Um, so yeah, it's just going to tell you all the mistakes that we made, that I've made, and the things that I would like to know if I was starting again. So my name is Marcos. That's my Twitter handle there. I'll be posting the slides after the talk. And like I said, I work at Sky, especially the Sky Sports and Sky News team. Just by show of hand, like, do you have the Sky Sport app installed, by the way? All right, not too bad. And how many of you know this Sky as a brand? All right, cool. So yeah, so I've worked before in those teams, but I recently moved to a different team, literally 2 weeks ago, called MySkype. And that's the app that we build for our customers so they can go and check their bills or get any new TV packages and so on and so forth. And let me begin with this phrase. Common sense is not that common. And this actually doesn't mean that people lack common sense. What it really means is that common sense is based on human experience and people's individual perceptions. So my idea of common sense is nothing but my perception. And it's likely to contradict someone else's idea of common sense. And what it really means to us is that everything that I'm going to talk today is based on my own experience and the way that we work at Sky. So don't take everything that I say for granted, because some of those things might not work for you, because we might be using a different approach. Because when you're modularizing your code base, you could do it in so many different ways that it's very hard to just come to a one single solution. But we're here today to talk about Sky Sports. So this is our app for the UK. And we don't only support the UK, we support more countries. So we support UK, obviously. We also have support Germany, support, Jesus. We support Italy, and we also support Spain, and actually a few more countries like United States, Canada, Australia, and weirdly enough, Nigeria. I'm not sure why. And you might have noticed a pattern here is that I've been using different colors when I was mentioning some of those countries. And the reason is because we don't have just one app. We actually have multiple apps. And they have different backends. They have different designs in some cases. They might even share like a few features, but they're going to be, they pretty much are always like a few differences on those features. So it's kind of like a crazy world to live in, to be honest. And so which kind of strategy are we using to do this? Like where we began. And the underwhelming answer is Flavours. So Flavours, I think, will have been perfect if we indeed had a white label app that we could just change some assets here and there and then create another app for like Germany or Italia. But unfortunately, that wasn't the case, because I just told you that we have different backend systems and we have like different stuff really that doesn't really work well together. And in case you don't know how Flavours works, I'll give you the gist. So this is a structure that you're going to end up with. You have an app module. Then within the app module, you have typical source packets. Within that, you have main, where you write all the code. But with Flavours, you also have to add a new package for each of those flavors. So let me simplify this and zoom in a little bit and just get rid of some of those flavors. So let's say that we only have UK and we only have Italia. So if I want to write a feature that could be shared across those flavors, I can just put that feature in main, and then it's going to be available for UK and Italia. And obviously, if I write a feature that's only in the UK flavor, then that one is not going to be available for Italia. The problem with this and with Flavours, when you have like different features or the same feature that should behave in different ways is that if I now want to change something in that feature one because the UK product manager, for whatever reason, wants something different, I'm going to do the work there, and UK is going to be fine. But because I didn't know, or because I really didn't do my job properly, that Italia was also using that feature, now I've broken Italia. And also your real example. So this is back in 2017 when we were working on the Italia, Germany, and UK app at the same time with a hard deadline as well to release the three of them. And so that means three different teams working on the same code base that is obviously not modularized, using Flavours, which is not a really good approach for this. So what happened here is that someone changed color in Germany, thinking that, well, this is just going to affect Germany, but it actually affected UK. And the, again, word there should tell you that that wasn't the first time that this actually happened. And what's actually quite funny is that it wasn't even going to be the last time that that was going to happen, because not even a week later, we had the same bug regress. And we can talk about testing and why this wasn't picked up, but I'll come back to testing at the end of the talk. So this approach just doesn't really work. With Flavours, and if you were in one of those talks earlier before about Dagger, you probably know that you're going to have very long build times because you're going to have to build pretty much everything. So that doesn't really work well. We have the problem that you change one thing in UK and then you might be breaking things in Italy or any other apps. It is very, very painful to work with, especially for testers, because they have to test multiple apps if they're doing like manual testing. And obviously, it doesn't scale. Because if our goal is to have 20 apps for 20 different countries, this is just pure madness. And once you get to this point, or maybe you have like a different case where you just thought like, well, we really need to modularize our code base because it's just not working for us, you can do three things. You can just ignore the problem and carry on. You can leave the company or move to a different team. And the fact that I moved to a different team 2 weeks ago has nothing to do with this, I promise. Or you can try to change it. And that's what we usually try to do. We try to change things. But changing things is not easy, especially if you work in a big company like Sky. Because it turns out that convincing people is hard. It is very, very hard. So if you see this problem, you probably have to go and talk to your team, and you have to say, I think the way that we're doing things doesn't really work, doesn't scale. And they'll probably agree with you, because they are also been touching the same code, and they feel the pain. And so you can probably get to an agreement fairly quickly. The problem really is when you have to convince people that are out of your team. Like, I don't know, your head of engineering or your head of product or whatever. Because you have to sell the idea that modularizing is going to be good for everyone, not just for you as a dev. And once you have a product that is doing well, making a case to refactor it or to rewrite it might not be as easy as you think. Because you're still going to have deadlines. You're still going to have to ship features. And someone has to pay for this work. Modularizing your code base doesn't come for free. And that is a very, very difficult thing to sell. So like I said, we've been modularizing our code base for a year and a half, but we got the budget to have a team to focus on modularizing literally a few months ago. That was in November. So until then, it was mainly probably me and the other senior devs like trying to get to an agreement and trying to think how we could do things and trying to move that forward. But we didn't have a budget to actually do it. And it took us a year to convince someone up in the chain to give us that money. And it wasn't easy, and it came obviously with its own caveats. One of them being the vision. What the people out of our team thought that we were supposed to do. Not what we wanted to do, but what they wanted us to do. And so there was this vision of how our apps should be built, because we want to have multiple apps as soon as possible. And there was also the concept of something called the showcase app that I'll come back to it later. So the vision was being able to build a new app by mixing and picking features from maybe a website, which we obviously didn't do. So if you have all these features here and you want to build a new app, they basically thought, well, you should be able to just create a new app, add like a toolbar, an action bar, whatever you want there. And then you could just pick, I don't know, feature one. And maybe feature one is just an article list. So that creates the article list magically. And then you pick the feature number 2, and that's going to add a video carousel on top of that article list. And you keep going, and maybe now you want to add the My Sky Sport feature or whatever. And so that was the vision. So to get that money, what we did was we showcased something similar to this. The only difference is that we built a plugin for Android Studio where we actually were able to build a new app from scratch in around 2-3 minutes, showcasing like an article list and a few more things, really. And that's one of the ways how we were able to get the money to actually get this team. So it's kind of like an interesting thing when you have to deal with people that are high up in the chain, because most of the times you can't really give them technical reasons. You really have to sell the idea. You have to take your developer hat off and put the seller one. And that is very, very difficult. I guess the cool thing about this is that because we knew what they wanted, it was quite helpful because we had to ask ourselves a very important question. Like, what is a module really? And how do you define what a module is? And because the main requisite that we had was being able to reuse features, we ended up with 2 types of modules, really. We had feature modules, not as dynamic modules, like Android feature modules. And then we have core, because everyone needs core, apparently. So let's get rid of core for now, and let's focus on feature modules. So what is a module? So for us, the way we saw it, a feature module is nothing but a black box that has inputs and outputs. And because we want to modify or specify some behavior within the module, we also have a set of listeners or callbacks or whatever you want to call them. So if you look at the implementation of this, the way it works is like the app basically sends some inputs to this black box. It gets an output, which could be an activity, a fragment, whatever, and also has to implement those listeners. And this whole thing brings us to another very important question, which is, what is a feature then? How do you define a feature? What are the boundaries of a feature? And I'll give you an example. So if we replace this black box with a feature called article list, this feature will probably have an article list activity or fragment, whatever you want there. But it could potentially also have a web view activity, maybe. Because when the user click on an article, we want to take them to a web view just so they can read the article. So the question is, what do we do with this? Like, do we keep that web view as part of this module? Or we just separate that into a different module? And we can then call that article reader. So our app is going to implement the on-article click listener, which will take the users to this other module. And this thing, which could be very simple in this example, it could get tricky. So let me talk to you about the first feature that we moved to a module. It's a fun story. So this was the structure of our app back then. So we have our app with different packages, pretty much like separated in features. So each package was a feature. And we had this one called streaming, because you can stream from our app. You can stream different channels. So this is the first feature that we picked. And it was just out of necessity, because we had a hard deadline to release a new app, which couldn't have this package for legal reasons. So this is what we did. It was supposed to be an easy decision, so we started with this. But we also had something else in this package. We had our live TV section as well, which is the section that shows all the TV channels, and then once you click on one of those channels, it takes you to the actual streaming. So the question was, do we separate this into like 2 different modules, or do we keep them together? And for a lot of reasons, we kept them together. And I can tell you that a year and a half later, we're still massively regretting that decision. If you go to our team and you say the word streaming, everyone just runs away. It's that bad. So we started with an extremely complicated feature, a feature that was built a while ago, and not a lot of us knew how that thing actually worked. And we had a hard deadline as well. And the worst thing, I think, is that the whole work was mainly done by one person. A person that, by the way, left Sky the day he finished the module. So it was a very, very bad example, because we here like trying to build our first module, which should be seen as an example for the next ones, and we're rushing it. And it was mainly done by one person. It was a very, very bad first example there. So where do you begin instead? Like, what do you tackle first? And you could say, well, start with the easiest one. I think like after like 2 or 3 months, like refactoring what this other person did and battling with Dagger and whatnot, I started with our very first module. And I thought, well, let's go with the easiest one, just for the sake of simplicity. And I built this, which is pretty simple. It's just a splash screen. The problem with the splash screen is that it doesn't really have anything. It's just a splash screen. So we never actually integrated this module with our app, because it was simple. It was working. We really didn't have the need to have this. So maybe instead of starting with the easiest one, you should start with the most valuable, the module that's going to give you more value. Because, again, you have to sell this, right? So if you say, hey, I have this new splash screen module that doesn't really do anything, that's a hard thing to sell. But if you say, hey, I want to modularize our video player because we know it's a pain point for all of us to integrate that in a new feature, and while we're doing that, we're going to be able to fix a lot of bugs, that's a very simple and easy thing to sell. And that's how you can get like people like product owners and head of products and things like that get on board with it as well. And of course, integrate the modules as soon as possible. Don't make my mistake. And trust me, it's going to be ugly. And it's going to be hacky, because your app won't be ready for this. Last summer, we renovated our bathroom in our home. And before we could have this beautiful new bathroom, we had to go through hell before. And this is kind of like the same thing. It will get ugly before it gets better. But as long as the ugliness and the hackiness happens in the app, you will be fine. And I know that sounds really bad, but what you don't want to is to compromise your modules, because your new feature modules should be the standard to follow. And as long as you keep modularizing the rest of the features, all the hackiness will eventually disappear from the app. So don't be afraid of integrating as soon as you finish a module, because the worst thing that you can have is a lot of modules that are not being used anywhere. And trust me, because I've had a few of those. I guess now is probably a good time to move into one of our favorite topics, dependency injection. So back to our app and streaming module example. We also have a core module, like I said, because everyone needs core. So app and streaming depend on core, because we still have features in the app, so we need that dependency there. And obviously, app depends on streaming, because we need that. So the problem comes when the streaming module needs something like a user, and a user that actually exists in the app. And it's been indeed used by different features within the app. So somehow, streaming also depends on the app to pass a user object across. So this is kind of like what we had, having to pass the user from the app to the streaming module. So before we started modularizing, we were already using Dagger. Quite simple implementation, I'll say. We just had a main component, like an app component with few modules. And then we had, for each feature package, we had a subcomponent. So nothing fancy there, quite easy to follow. I guess the question is, was this still useful? And this is not a problem just with Dagger, but with everything that is a bit difficult to understand. So what I'll say is, if you don't want to understand something, just don't use it. There is no point on using something that you don't want to understand, because you're going to end up copying, pasting code from Stack Overflow and pasting it in places that they don't really belong to, and you're going to create bugs, and you're going to create like weird secondary effects that no one is going to be able to understand. After this whole infamous streaming module thing, our implementation of Dagger changed a lot. And it went from something very understandable to a very complicated code. And I'll show you some snippets. Like, this is real. It's in Java because it's like a year and a half ago, something. So here we have a provides method, right? Nothing special there. We're using a singleton because we want that instance to be a singleton, so we want to use that scope there. But for some reason, that wasn't good enough. So we also had to do our own implementation of our singleton using an atomic reference because I don't know why. Or this one. This is another example. This is the player activity inside streaming, where we inject this utility class. But of course, we have to check before that utility class hasn't been injected before, because, yeah, I don't know why. And if you look below that, you'll see the streaming module main thing, which you might be wondering, what the hell is that? Well, that's something that implements this interface, right? And then I can just keep going, really. Like, I can go now, what is module helper? What is this other interface? And then I can go, what is this base nav object registrar, whatever the hell that is? But I'll save you the pain. So we ended up with something very, very complicated, and all because we were using some components. And whoever did this didn't want to understand how that would work. So he thought, let's keep using subcomponents without really looking at what was going on behind the scenes. So put this all together with a hard deadline, and this is the place where you're going to end up with. And well, the problem with some components is basically one of them, actually, is that we have our component in our app, we have our subcomponent in the streaming module, and you can see that the app needs to know about the streaming subcomponent, so the dependency goes from the app to streaming, which is fine. But if we now go to the activity where we do the injection or the fragment, you can see that in streaming, we also need a reference to the app component up there. So now we have a cyclic dependency that just doesn't really work. And that's why we ended up with all those weird interfaces and things, and yeah, very painful. So instead of using subcomponents, you could just have a look at how Dagger works and get rid of that. And just use like normal component dependency. And this is how it works now. So we don't have a subcomponent anymore. We just have a component that depends on a core component, which is in the core module, because that's where all the things that we want to share live. And now the way we create all these components is based on an interface. So each of our components that we need in our app has this interface, this app component provider or streaming component provider or whatever. And then we just implement that in the application. And this is kind of like the code of the core component there. But it's the same one for the app component as well. So quite simple. You always have the same component, and then you return that component unless it doesn't exist. And because we only want streaming to be in the UK, we can just extend the Sky Sport applications from the UK Sport application and implement there the streaming component and just do the same thing. So we extend from Sky Sport application, we implement streaming component provider, and because now we have access to the core component that we created in the Sky Sport application, now we can do this. We can add that dependency there. And that just works. And because, again, it depends on the Sky Sport application, we also have access to the app component. And now we can pass that user through. And once you put this together, and when you try to do that in an activity, it kind of looks like this, because the only thing that you need is really an application context, because your application is going to be implementing those interfaces. And just for simplicity, we have like an inject helper that does that work for us. And it looks like this. It's quite simple. Takes a context, like an application context, checks if it's implementing that interface, and then returns the component. Way more easier than all the stuff that I showed before. And it's also worth noting that we only do this for these 3 components because the other modules, they have their own component and they don't really need anything crazy. So we don't really even have to create them in the app. We can just create them in the module. And then we just pass a context. And that's how it works. So takeaways are quite simple. Understand what you do and share the knowledge. Because it doesn't matter how good your solution is if no one else is able to understand that because you haven't shared that before. Which brings me to another hard lesson that I think we learned, which is following the KISS principle, which, as you know, is keep it simple, stupid. I know a lot of smart people that come up with crazy solutions that, even though they work, nobody understands, like what we saw with Dagger at the beginning. So if you think that you are too smart to fail, and I kind of thought I was really at one point, I'll tell you something. No one cares a lot about how smart your solution is. Because if the whole team where you work with, they cannot understand the solution, you have already failed. And I'll show you more examples. This is something that I actually wrote a while back. It's in a Dagger module. So what I'm doing is I'm just injecting like a bunch of factories into a map, and then just using like specific key for each of them. And basically, then we use those factories in an adapter and whatnot. And I thought it was cool because I was using into map when into map was something new in Dagger, and it was nice, and I thought it was cool. But you can do the same thing just by doing this. You can just have a normal provide method and put all that stuff in a map. And this is arguably more understandable than the other stuff. This is another example. I'm quite fond on this one. We have some configuration in our app that comes from a JSON file. And this is the implementation of that JSON file, right? We have this config class, which has a map, string as a key, and a config section as a value. And this is a config section, which is an interface that gets a name, all that stuff. But to make this work, you also had to write the serializer. And this is kind of like a base deserializer here. And you can see that you also need a config section deserializer there. And of course, because what we saw with Dagger before, this is kind of like similar. That's an interface that does some things there. So if you wanted to deserialize one part of that JSON, of that config file, you had to write something like this. You had to write your own deserializer, implementing config deserializer, and then create this new class there called force upgrade, because this is just for the force upgrade section of our app. And then the force upgrade class is the one that implements the config section that we saw before. And if you got lost, that's perfectly fine, because I got lost too. And if you don't think this is mental, it's probably because you wrote this code. So one day, I just changed this. And this is the actual commit message that I wrote. And I have to tweet about that. Almost 3,000 deletions for a JSON file that the only thing you had to do was pass to a config. That's it. It was a very, very good indeed. So while modularizing, it's very easy to complicate things. It's very easy to add way more modules than what you need. And you're probably going to end up creating a big, big mess. So simplify everything as much as you can. And maybe that means asking questions like, do you really need a core module? Because, I mean, you probably do, but it's very easy to get carried away and just blow it up with a lot of classes that you don't really need there. So let's go back to the streaming example that I showed before. So we needed a user in streaming, but we also needed that user in other features that we have in our app. So one option here could be, well, let's just move that to core. Because like streaming and app, they both depend on core, so we can just move that there. And that's reasonable, that's fine. But what if then you need another feature module like the about section that also has to implement core because it needs some other stuff there? About doesn't need user. Why should it care about user? What if you have more stuff there, like other third-party libraries or other classes that you put there? Like about doesn't really need to know about them. It doesn't need them. And you could argue then, well, let's just create a new module, and we'll just put the user class there. But remember what I said before. It's very easy to get carried away. So now we're just creating way too many modules. So instead, maybe, what we could do is, well, let's forget about the user streaming. Let's have our own implementation of a user there. So that streaming user class lives in that module. It doesn't live anywhere else. And then it's up to the app, to the application, to fulfill that dependency. It will transform a user into streaming user. And now your streaming module doesn't really depend on that user class anywhere. So if think very carefully when you have this kind of like problems, or when you have to think about where do I put my classes, because there's probably a better solution and an easier solution than just moving that to core or any other module. And in fact, I think if you treat each module as it was a library that you wanted to open source, I think that should potentially fix a lot of those issues. But then again, it might create way more overhead than what you need. Because if your goal is not sharing those features with other apps, like our case, then maybe you probably are creating more problems for yourself. So like I said, common sense is not really that common, so keep that in mind. Let's talk about testing a little bit as well, because you obviously need to test your modules. And I mentioned this showcase app before. So the showcase app, I'll explain what it is. It was this idea of that we should have an app where we could put all the features with all the different possibilities in the app, so we could just showcase that to product owners or anyone else, so they could just pick the features that they liked. And the idea was that all the testing should also be done here, which is a very bad idea. So imagine that, like try to do that. Try to build an app, just get 5 random libraries, and try to implement every single option within those libraries in that app, and then test everything. Craziness. So what we did instead, rather than having one app with all these features here, we just say, you know what, let's don't do that. The problem is that we have already invested a lot of time there, and it wasn't really working, because you saw at the beginning that the tests weren't really working very well for this. So we get up with this, and instead what we do now is we have sample apps. So we have one sample app per module, and it kind of looks like this. And I think this is just better, because it helps us make sure that we don't break any feature. It lets us test every single feature in completely isolation without having to integrate that with our app. We can work with those features without having to think about how can we integrate that with our app. So it helps us to clean our features module clean. And like I said, the implementation might be a bit ugly if your app is not ready yet, but that's kind of like the price that I think we have to pay to keep our modules clean and decoupled. Another issue that we face, which is also related to the color thing that we saw at the beginning, was resource conflict. And this is something that you might have experienced when using third-party libraries that they have named the resources in using very common names that you might have as well on your app. So this is like an example. It kind of looks like this. So here we have 2 modules, core and streaming. So we have streaming named test, string named test in streaming. So we run that, and that's this string that we see there. But if we now go and create a same string with the same name in core, then what do you think that's going to happen? Like, what's the result going to be? And the result is we get the string that's in core. And the only reason is because the dependency that we declare first, which is core, has priority over the other ones. So if I now go ahead and swap them, and I put streaming first, we're back to the first scenario. And then, of course, if I define that string on my app, then that's the one that will take priority. So how do you fix this? Quite simple. Just prefix every single resource in your modules. But then again, you might forget about that. But you can add something quite cool, so you don't forget about this. And you can add a lint check. So in your Android section, in your Gradle file, you can just add this resource prefix followed by the prefix. And that'll make sure that lint will throw an error if you haven't prefixed that string or that resource. And there's also another thing that we kind of like introduce. It's the concept of private resources, I guess we could say that. Because you can kind of like override resources in your app module from the other feature modules. And that's something that for us is quite helpful because sometimes we just want to change one color for a specific app. So we can just go to the app, change the color there, and that just works. But there are some resources that we didn't want anyone to change. And you can't really enforce that, I guess. So the way we did it, which is all right, I guess, is that we said, right, if a resource starts with an underscore, it has an underscore as a prefix, then we're going to treat that as a private resource. And so then we can pick that up in a PR or a merge request or whatever you do there. And I'm actually thinking it might even be able to add a link check, a custom link check maybe for this as well, but I have no idea. So that's how you know that, well, that's how we know that you can really do that stuff over there. And to finish off, I just wanted to share just one more thing that I think is quite useful. So I'm not sure if you're aware of something that Android Studio has, which is scopes. So you can define scope in Android Studio, which is very convenient when you're dealing with a lot of modules, because it lets you focus on the module that you're working on. So you can just go to Android Studio Preferences, Appearance and Behavior, and then you have there the scope section. You can add a new scope. It can be local. You can share that. You can define that scope using regex to include the files that you want. So now back to the IDE. If you go to the drop-down where you can select the project view or the Android view, you also have the scope now as well. And if you go to that one, then your the whole project view changes to only the files that you have there. So quick recap, and I think the most important things is that for us at least, the app is the glue that holds everything together because we want to be able to change the implementation of like some stuff that's happening inside the features. We want to be able to say, from our UK app, we want to take the user from this screen to this other one, and from the Italian one, maybe we're going to do something different. So we need that. And the app is the only place that we can actually do it because the app module is the one that knows about every other module. I think if you treat your features as libraries, I think that's a very, very good thing. Don't think about how you're going to be able to hook your new feature modules in your app, but more about what will you do if you wanted to open source that module. Because it's a different completely mindset, and I think it helps a lot. And finally, just simplify everything. I got this quote from John O'Reilly, a dev from Cisco, literally a week ago. And I just couldn't agree more. Like, I think everything should be as simple as possible, but not simpler. And just paraphrasing John, many people seem to veer towards adding unnecessary complexity very often. So simplify. Just try to avoid this. Thank you.